Aloha guys, this is Dr. Tom Walker coming at you from somewhere in the Hawaiian Islands. Aloha. Okay, we're going to start a new topic today. Up to now we've been talking about strange energy in a strange world. Now we're going to start on something even more strange, probably, arguably, and that is adventures in consciousness. Some would say that consciousness is the biggest mystery that exists in science and philosophy and other endeavors. So let's take our first step into consciousness. And I'm not conscious enough to select the proper slides. No, this jumping around, you know how all this stuff is. Okay, the hard problem of consciousness. Consciousness has been a mystery since time immemorial. If we do an investigation of the research into consciousness, one of the first names that pops up is Dr. David Chalmers, an Australian philosopher. And his name is at the top of the list, so I'm assuming he's an absolute world authority on consciousness. Okay, 1995, Chalmers termed it the hard problem of consciousness. And in a very short time, it was shortened to just the hard problem. Scientists have a difficult time understanding and explaining consciousness. At its most basic, consciousness is defined as sentience or awareness of internal or external existence. Sounds pretty good. I would think that's a good starting point. It's been described as being at once the most familiar and most mysterious aspect of our lives. Why? Well, we're using consciousness to try to evaluate consciousness. Sometimes it's thought to be synonymous with the mind. At other times, it's thought to be an aspect of the mind. It appears to be awareness or awareness of awareness or self-awareness. And there might be orders of consciousness, or they might be differing aspects of the same thing. The mystery of consciousness. This is a friend of mine, Dr. O. I like the picture and thought I'd put it in here. Doesn't that demonstrate consciousness? Okay, one of the big things that Chalmers talked about, one of his, something he puts a lot of effort into, a lot of emphasis, that's the better word, is experience. Conscious experience. Chalmers describes it as what it's like to be something. Okay? Even when we have explained the performance of all cognitive and behavioral functions in the vicinity of experience, perceptual discrimination, categorization, internal access, verbal report, there must still remain a further unanswered question. Why is the performance of these functions accompanied by experience? No. This is from Facing Up to the Hard Problem of Consciousness. Author Annika Harris described the hard problem as the question of how experience, and this one I like quite a bit, how experience arises out of non-sentient matter. Chalmers didn't stop there. He said there was an easy problem as well as the hard problem. But we're going to see very quickly the easy problem is not too easy. But relatively speaking, it is. The easy problem are things like how our sensory systems work and how such data is processed by the brain, and the neural processes of thought and emotion, among other things. The easy problem. Of course, there's nothing easy about the easy problem, as we'll see momentarily. However, they can still be analyzed with reductive inquiry. Experience is unique. The difference, Chalmers argues, is that experience is not logically entailed by lower order structures and functions. It is not the sum of its physical parts. This means that experience is impervious to reductive analysis, and therefore poses a hard problem, and that's what makes it hard. Many questions remain. Are animals conscious? Are plants conscious? What about rocks, planets, moons, stars, galaxies? And what about the mind? Is there really a mind? And if it is it in the brain? Does it exist separately? Is it a misnomer for just another way of talking about the brain? And of course, the big one is, does consciousness reside in the brain? Or perhaps even a more fundamental question, does the brain create consciousness? The human brain. Okay, Now, it should come as no shock at all that if we examine the research and the writings and statements and papers from the orthodox scientists, they are quick to state that consciousness and the mind and stuff are all phenomena of the physical brain. And the physical brain and all the accompanying structures is known as neural correlates of consciousness, NCCs. Since about 1990, researchers, including the great Francis Crick, one of the co-discoverers of DNA, molecular biologists, have made significant progress towards identifying which neurobiological events occur concurrently to the experience of subjective consciousness. These are called the neural correlates of consciousness, or NCCs. However, the research addresses the question of which neurobiological mechanisms are linked to consciousness, but they still don't answer the question of why they should give rise to consciousness. This is the hard problem of consciousness that David Chalmers describes. Among the orthodoxy, of course, it's all seen as a function of the brain. Now, that's a tempting point of view. Why? Because depending on who you speak with, many believe the human brain to be the most complex object in the known universe. I guess if you consider it the most complex singular object, because wouldn't a galaxy full of other creatures and all the people on Earth and all be more complex? That's for another day. For starters, there are estimated to be 100 billion neurons in the brain. Neurons are functioning nerve cells. Approximately the same number of stars in the Milky Way galaxy. Now, just the other day, I was reading something and it said that there are 200 billion. So, who knows? The complexity is off the scale. Neurons have structures called dendrites that join with other nerve cells, and axons, structures that transmit nerve signals and bundle together, and what we call nerves. So the nerves running down our arms and so forth are bundles of axons. The number of neural interconnections between these structures is staggering. But first, we have to briefly address a problem. People tend to view science as exact. And in many ways it is, and hopefully they certainly attempt to be. They automatically accept the facts given by various scientific disciplines as true and correct. When we start researching the literature, we find that often that may not be the case. The big thing I've seen, guys, throughout my lifetime, I've been a science geek since I was a kid, is that these numbers keep expanding. Of course, that's not a bad thing. I mean, as new research and studies and conclusions and mathematical treatments show all this, I suppose that boundary keeps being advanced. But let's keep that in mind and realize that every time we come up with something new, hey, that's not the final version, probably. That's the thing. Neuroscience is no exception. Now, here's a couple of interesting pictures. Here's a neuron. Now, there are neurons all through the body because they're nerve cells. What the hell is Kim Kardashian doing and Kanye West on my computer? When I'm trying to tape something, my God, what an insult. But it was from Rolling Stone, so I'll forgive them. All right, here's a neuron. Here's a galaxy. Now, there are only 27 orders of magnitude between the difference between the two. But they do have a pretty strong resemblance. The most quoted number of neurons in the brain is the familiar 100 billion, the same as the number of stars in the Milky Way galaxy. Yet another source said this was a vague number that I saw, and it's actually 86 billion. Okay, we're not going to quibble over 14 billion, right? But a Scientific American article had it at 200 million. And just the other day I was reading something, and it listed it at 200 million. But when I was recently, this is February, recently when I was researching this stuff and writing all this up, what I saw consistently was 100 billion. Who's going to quibble over 100% of error? Okay, in addition to the number of neurons that we also have a number of neuroglia, or glial cells, which are supporting structures, 4 different types. And there's an enormous number of those too. Now we're still talking about neuroanatomy right now. Neurons are the actual working cells of the nervous system, but there's an extensive supporting network of neuroglia or glial cells. They support and protect the vital neurons. Initially, it was said there were 50 times the glial cells as there are neurons, a titanic number. But a few years later, they dropped it for 10 to 1 instead of 50 to 1. However, as researchers looked into it, no one could verify where this number came from. And I found this in my research. So this is 1 trillion glial cells. Impressive to say the least. Scientific American in June 2012 attempted to track this widely accepted fact down and couldn't find anything. Eventually, it was decided that there's less than a 1-to-1 ratio, less than 100 billion glial cells. But, okay, we can dig that. It's still unimaginably complex, okay. The brain is incredibly complex in other ways, because in addition to all the neuron connections, now we also have the synapses, the tiny gaps filled with chemical neurotransmitters that are found all throughout the nervous system. The interconnection between neurons called synapses, tiny gaps filled with chemical neurotransmitters, are huge. The average neuron is said to have 10,000 connections with other neurons. Unbelievably, unimaginably complex. In the cerebral cortex, the thin outer layer of gray matter that is just superior to the cerebral hemispheres, where the so-called highest of higher functions take place, there's said to be 125 trillion synapses, equal to the stars in 1,500 Milky Way galaxies. Are neuroscientists want to be astronomers? Now I like it. I think it's cool. The complexity is so great that a cubic centimeter of the cerebral cortex is said to, you guessed it, have as many connections as there are stars in the Milky Way galaxy. Now, this has been fun and informative, but there are 2 points I want to make. We will see over and over again that many scientific facts just pop out of nowhere, sort of like virtual particles, and are not carved in stone. Question much of it. More importantly, in spite of the staggering complexity of the central nervous system, the brain may not be the center or origin of consciousness or the mind. I know, that's a bold statement, and a lot of people would be PO'd by that. This has been the center of intense debate for decades. What is consciousness? What is the mind? Are they in the brain? Well, of course they're in the brain. Can the mind be something else? Neuroscience, of course, believes the brain to be the source of it all, as do all materialist reductionist scientists, which is all the mainstream people, naturally. Science works like this. Everything is an accident. Things evolved like they did for no particular reason. The universe came to be with the Big Bang 13.7 billion years ago, and everything else is just coincidence. Period. We have no function, no purpose. Although we have developed complex psychological constructs to make it seem as though our lives have purpose. But in fact, it's an accidental happenstance, according to the most accepted scientific beliefs on the matter. Since this is all there is, of course, consciousness and the mind are just products of the neural tissue of the brain. It's more complex than the Milky Way. Any feelings of spirituality or higher purpose are utter nonsense. The brain cooks it all up to make us think we matter, to give us a purpose, to make us get out of bed in the morning, to keep us from jumping off that tall building. Great, but what are the vast numbers of accounts where full consciousness and the mind are present without the body and the brain? I'm talking, of course, about out-of-body experiences and near-death experiences. Now, these have been extensively studied for a long time. Sure, they can be explained by hallucination, anesthesia, illness, but there are documented cases where people who are blind from birth or blind from their early neonatal time, where they were put in like Stevie Wonder, unfortunately were put into an incubator with too much oxygen and destroyed the optic nerves. These people are able to describe what they heard while they were having surgery, life or death, from their relatives and friends out in the waiting area, and also what's going on in the operating theater. Now we're running out of time, This is where we'll start next time. Be there or be square. Dr. Tom signing.